Hello 6-2 students, it's been a while since I've been able to see you in person. Today I'm going to try a video to help you with lesson 7.1 where we are writing algebraic expressions. So this is a supplement to try to help you get through that assignment that's coming from Gronsky right now. Today you're supposed to be taking notes, and then Tuesday of this week you're supposed to be working on the assignment, and I want to kind of show you those pieces. So I've given you here something that I found online. I use it each year. It's from palmbeachstate.edu. It's probably something you could look up. I'll also connect it or link it in Classroom so that if you want to print it, you can. My printer isn't working so great. Neither is my video recording hanging from a chandelier here, but we're going to do the best we can teaching from home. So if you take a look, I like this sheet because it breaks it down into all the different operations that you're familiar with. So whether we're talking about addition, subtraction, multiplication, division, we're gonna have to deal a little bit with powers, and if something is equal to, that's when we get to equations. You'll see some terminology like that. So for today's purposes, I want you to think back to your elementary days where your teacher had on the board some keywords that you knew, if you read them, they had to do with addition. Things like more than, or sum, or total, or if something is added to. You recognize these words for subtraction that came from your subtraction poster years ago. Minus, less than, decreased by, less. Those all mean I'm going to take something away, right? Or you might add the words take away. Here in multiplication, you recognize words like times, or product, or double, or multiplied by, or this word of. If I have groups of, it's telling me to multiply. The last one that we're really going to tune into today is division, where it talks about quotient, or if something's divided by, or if I'm looking for a ratio, that's also a division. So the reason why I have my highlighter out here, if you're able to print this document at home, great. If not, maybe you just write down these keywords that we highlight. So I want you to take a look in just addition first, and I want you to see if there are any words that we could write or think of in backwards terms. What I mean by that is when I say I'm going to take a number plus, I don't know what that says, a number plus 3, I actually write it, the variable, that's that unknown, plus 3. So I'm just taking the word form and I'm translating it into an algebraic expression on the right. Well, this goes directly in order. The words a number means some variable, and they used x for all of these. And plus 3, exactly the same order, right? Take a look at this next one though. It says more than, and it says 10 more than a number. Well, over here, instead of starting with the 10, notice that they started with the mystery number, the piece of variable, or the piece of algebra, which is represented by a variable or a letter. So they instead started with x plus 10. That's because of those words more than. So if we see that, we're gonna have to think a little bit backwards. I like to call these backwards words. So I'm just gonna highlight that one for you in pink so that you can see it. That's one that I would write down for addition. You have to remember to work backwards. Well, let's look through here. Sum. Well, the sum of a number and 5. Well, first they gave me the mystery number, also known as a variable or a letter, and they added 5. That goes directly in order from left to right like we're used to seeing. If they asked me to find the total of 6 and some number, well, 6 comes first and some mystery number comes next. That goes directly in order from left to right like we're used to. What if I have a number increased by 2? Oh, there's the mystery number first, and increase means add, and they're adding 2 at the end. What about this one? Added 2. 11 added to a number. Ooh, this one's interesting. They said 11 first, but they wrote it last. This is an example of those backwards words where we have to think a little bit backwards with our expression. If I'm going to add something to you, first I have to go find you. So if I'm going to add 11 to a number, first I have to start with the number. I have to find that number first. So again, these are just two examples of what I call backwards words. It might help us when we move on to lesson 7.1's assignment. Next, let's look through subtraction. I want you to notice if there are any examples of backwards words. Some of you are probably starting to get the hang of this. So if it says minus, a number minus 7, well, that just goes in order. A mystery number, also known as a variable, minus 7. Nothing backwards about that. Maybe you notice less than. It says I want 4 less than a number. So instead of starting with the 4, which they said first, they started with the mystery number or the variable. This is another example of backwards words where we have to think about this expression in reverse, turned around a little bit. Here we have the word difference, and if you notice, this goes directly in order. Mystery number, take away 3, there it is. How about less? 9 less a number, start with a 9, take away a mystery number. Nothing too confusing about that one. Do you see any other backwards words happening here? Ooh, how about right here, subtracted from? Their example in word form says 6 subtracted from a number, but they didn't start with a 6, did they? They turned it around. It's backwards. If I'm going to take something away from you, first I have to go find you. And I was just kidding. I'm not going to take anything from you today. We're going to look for the same ideas in these following examples, but more than anything in multiplication, I want you to notice something. When we write multiplication algebraically, what is it missing? There's no need for a multiplication symbol, right? There's no times symbol used. Instead, if I want to show you 8 times a number, I put the 8 right next to that mystery number or variable. If I want to show you the product of 14 in a number, that 14, it's actually called a coefficient. It sits right in front of the mystery number or the variable. So I actually read this as 14x. That means 14 times x, or 14 times a mystery number. What if I read twice a number, double a number? Well, if I want to double a number, that means 2 times it. So to show that, I write 2 times that number. No symbol needed. I write that 2, called a coefficient, right in front of the variable. That's something I want you to notice with multiplication more than anything. And the next section here shows me division, and I'm not so worried about backwards words. What I'm more concerned about, and I want to highlight for you down here, is the form that they show this in. So in the first example, quotient does mean divide. It means the result of a division problem. It says the quotient of a number in 7. So instead of writing x divided by 7, which would not be wrong, they decided to show it as a fraction. This fraction form is a lot more common in algebra. That's probably a more typical way of seeing your answers in your work. So something to kind of push you towards. We've seen that in class already when we talk about writing percents, right? We always write that percent over 100. We work a lot and talk about that fraction bar meaning division. Here's another one, 10 divided by a number. Well, the first thing they said 10, and it's going to be divided by a mystery number, so the 10 goes in the numerator. We divide it by x. Or you could write it out, and I think I probably should use a different pen for this. 10 divided by x. These both are true, but this is a more traditional way of showing algebraic expressions. Fraction form is where we're going to try to get you. All right, I'm going to stop here with my hints on this sheet. I want you to be able to apply this now to the beginning of lesson 7.1. You actually have a worksheet that looks more like this. I was able to print it at my house here with my printer, but it's got a lot of weird missing lines through it. So I decided to rewrite the assignment. If you don't have a printer or your printer is acting up like mine, you might have to do something similar. So you go to Gronsky's assignment, lesson 7.1, and you copy down what the problem says, okay? Or you even just show me the work that you get from that problem, which is fine. I'm going to try to walk you through how to use the notes examples that I just gave you to apply to your assignment. So right here, lesson 7.1, writing expressions. I've titled my paper so she knows what it is. And number 1 tells me to find the sum of k and 8. I'm supposed to take this idea of sum of k and 8 and turn it into an algebraic expression. Do you see this keyword sum? Look back at our notes here. Where did we see the word sum? Oh, I see it here in the addition section. So I'm going to underline the word sum and remind myself it means we're going to add. Is it highlighted? Are those backwards words? You'd say no, they're not. So I'm just going to put in order k plus 8. That's the answer she's looking for. Number 2, what's the key word here? Something that we just saw on our notes page. Oh, it says the difference. Difference. I'm going to underline that. That means if I look here at my notes, difference. Oh, that's in the subtraction section. I see it right here, and it's not highlighted, is it? But then it goes on to say y less than 10. Oh, that's another way of saying subtraction. But here they use the words less than. And I'm going to underline them in a dangerous sort of underline. I'm telling you to be careful. I recognize right here that I highlighted for you. Less than is an example of backwards words. We need to turn those around. So whatever they say, I'm going to write in reverse. If it says y less than 10, I really need to start with the 10, and I need to subtract the unknown number or the variable. 10 minus y is what she's looking for. I'm not going to do all of these for you, but I am going to help you find some keywords. So for number 3, what keyword do you recognize? Do you see one that comes from our notes? Hopefully you notice the word product. And you would look here and see what section product was in. Product is in the multiplication section. So I'm going to put a little multiplication symbol above it so that I remember I need to multiply. And I'm also going to look at this hint which says I don't have to use a multiplication symbol as long as I write the number or the coefficient right next to my variable. So in a moment, you're going to show me how to turn the product of G and 7 into an algebraic expression. Number 4, we're looking for the quotient of H and 8. Oh, I see a key word right here, quotient. It is not highlighted on our notes, but it does go with which operation? Division. And remember the hint that we wrote to ourselves down here, or we showed ourselves down here, is that we're trying to write that as a fraction. A fraction form is what we prefer. Number 5 is similar. It says subtract 6 from 5W. Oh, I noticed this word subtract, but the word from also goes with it. It's a lot like something we highlighted on our notes. In fact, maybe I should have used the dangerous underline. Subtract from. Well, it definitely goes with subtraction, but if you remember, those are those backwards words. You need to be careful and turn them around. So even though it says 6 first, you're going to write the 6 last. And even though it says 5W last, we're going to start with it first. So I'm going to take 6 away from 5W. This is what you'll see for your expression. I starred the next few problems because I noticed that they're a little more difficult. There's multiple steps to them. So I'm going to walk you through a couple just to kind of get you thinking, and then I'm going to let you finish the others the best you can on your own. Number 6, it says add 10 to the product of Z and 7. If you notice, there's a couple dangerous parts here. It says that we're going to add 2. Well, if I look back at my notes, oh, added 2. I highlighted those. Danger, those are those backwards words, right? So they do go with addition, but I have to write that part in reverse. Next, it says the product. Well, product is a key word again. If I look at my notes, it's not highlighted, but it does go with multiplication. So I can remember that I have a certain way to show my multiplication. Well, if I want to add 10 to something, that happens at the back. Remember, those are those backwards words. I'm going to add 10 at the back. I'm going to do that last. So how would we start with the product of Z and 7? Well, if you look at your notes page, you would write the number right next to the variable. That's one way of showing the product of Z and 7 plus 10, or adding 10 to the product of Z and 7. Another way that your teacher probably would accept would be 7 times the variable Z plus 10. But regardless, we want to make sure that we're showing that addition of 10 at the back. Number 7, we have a couple keywords again. I have this word subtract from. I'm going to subtract something from. Ooh, if you look, those are highlighted. Those are those danger words. Change my lines here and remind you to work backwards with that one. And then it says the product of 4 and H. Well, product is one we just saw a minute ago. That still means multiply. So if I'm going to subtract 10 from something, I'm going to put that at the back. I'm going to take 10 away from whatever it is. And now the first thing I need to show you is the product of 4 and H. And if product means multiply, I could write 4 times H, just like I see on my notes page. All right. Let's find some keywords in the rest of this and see what you can do with them, and maybe I'll show you one more along the way. Number 8, add 5 to, add 2, those are those backwards words. You're going to have to add 5, but think of it in reverse. You're going to put that at the back of your expression. And next it says the quotient of S and 9. Well, quotient really means I'm going to divide. So I'll show you a hint here that we need to divide. So somehow I'm going to show you division of this variable S and 9. Probably going to look like a fraction. And next I have to add 5 to it. All right, let's take a look at number 9. Multiply y by 6. Ooh, multiply is a keyword. It's not highlighted though, so I'm just going to underline it. And then it says, then divide the product by 7. Then divide. Oh, then divide. And this idea of saying then divide the product, they just mean then divide the answer or whatever you get from your multiplication. So I'm just going to say that that's extra information I don't really need. Make sure that in this one we're going in order from left to right. First, show me the multiplication of y and 6. Then make sure you're showing me that we're going to divide it by 7. On this next one, number 10, a couple pieces to it. I think this might be the hardest one on this page. It says subtract the quotient of h and 3. subtract the quotient of h and 3. So it says subtract is a piece of it, quotient is a piece of it. And then it goes on to say from 4 multiplied by 4. Oh, I'm going to subtract from 4 multiplied by 4. Those are those backwards words. The subtract from we highlighted a minute ago, and quotient, if I go back, reminds me to divide. Let's see if we can work this one out together. So I want to subtract the quotient of h and 3. That's the thing I want to do at the back of my expression, the last thing. Kind of out of room. See if I can steal some paper here. Scoot that up and see if I can make it work. So I want to subtract the quotient. Quotient means divide. I'm going to divide h by 3. The h came first, it's my numerator. The 3 came next, it's my denominator. And next it says subtract that from 4 multiplied by 4. Oh, 4 multiplied by 4. Notice I have to show a multiplication symbol between these guys because they're both numbers. There's not a variable there. And if I just wrote 4 next to 4, it'd look like 44, wouldn't it? This is not a final answer. It's not wrong, but we can simplify a little more. Do you remember what 4 times 4 gets us? 16. And I'm still going to take away h divided by 3. This is the answer that we're looking for in number 10. The last thing I want to show you today is number 11, and I really want you to think about bar models. You saw bar models in Gronsky's notes today, or maybe the other day, depending when you looked at it, and I want you to try something similar with these. So number 11 says, Janet has P stickers. Amy has 10 fewer stickers than Janet. How many stickers does Amy have? Well, I want to picture this real quickly. Janet has P stickers. I'm going to draw a bar. I'm going to label it with Janet's P stickers. But Amy has 10 fewer. Well, she has fewer. What would her bar look like? It would be a little bit shorter, wouldn't it? And it would be missing this piece at the end. That would be 10 that I took away. So how would I figure out how long Amy's bar is? Maybe you noticed that I would have to start with all of Janet's stickers and take 10 away from. So I would maybe show that as P was the total stickers, and I removed 10. That's how many stickers Amy has. Sometimes I like to put my answer here, if it has 2 parts with a label, in parentheses. The reason why I do that is because I want you to know that all of those together represent stickers. If I didn't put those parentheses, it might look like I have something and I'm taking 10 stickers away from oranges or koala bears or something like that. So this is kind of just a way of showing our notation. If you see those parentheses, it's just telling you stickers really belongs to that whole total, or that total amount. Part B, Bernie has 3 times as many stickers as Janet. Ooh, so I still have Janet. Do you remember what she had? Same size bar. We'll call it P stickers. And next we have Bernie with her, and he has 3 times as many. 3 times. That's not exactly in my notes, but something similar. Times means multiply. 8 times a number. Oh, here it means 8 times the variable x. Well, for this one, I have 3 times as many. So it's kind of like taking 3 bars, the same length that Janet had, but 3 times. And each of those would represent the variable p, or the unknown amount p. So if I wanted to find a total for Bernie, what would I have to call that? Well, p plus p plus p, 1p plus 1p is 2p's, plus another p is 3p's. I could add them together, or I could just recognize that this means 3 times p, or 3 times the unknown variable. I'm just going to label this for us because it's a word problem. We'll give them words back. Notice I don't have to put this one in parentheses. It wouldn't be wrong if I did, but this is actually considered one term. What that means is this is just one number value. When I multiply this, it really only needs one label. Something to think about. And don't worry if that's not making sense yet today. Part C, Catherine has 6 more stickers than Janet. How many stickers does Catherine have? I want you to start again with Janet, and I want you to show me her bar model. And if you remember, she still has the same number of stickers. Catherine, it says that she has 6 more stickers. Oh, more than, in fact. Well, that's on our notes, and it tells us that we need to add somehow. So I'm going to let you think about how that bar model should look, and I'm also going to let you get me to a good answer. This last one says Dina has 2/5 as many stickers as Janet. So I still am referring to Janet. I know Janet still has that same bar filled with P stickers. But it says Dina only has 2/5 as many. So if I write Dina's bar here, I would probably make it the same length to start. But if I want to show 2/5 of a bar, I need to split it into how many equal parts? Hopefully you said 5, right? Because of the denominator. And she only has 2 of those. 2/5 get shaded in. This other portion, I might cross off and say she doesn't have that right now. And I want to figure out how to label this. So if you noticed a minute ago, I think we had one in here. If I look at my multiplication, I only want, well, it doesn't say the word of, does it? But I see something that reminds me a lot of this. So it says of means multiplication in our notes, and it says I want 3/4 of a number. Well, in this case, I want 2/5 of a number. I don't know what that mystery number is, but I have a variable that represents it. So what I'm looking for here from you is going to be a fraction times the variable p, or times the total that we started with for Janet. And when you're done, you're going to label it for me. And you'll be done with numbers 1 through 11 for lesson 7.1. I hope that my phone hanging from the ceiling here worked okay for you. I hope you can zoom in and see what you need. If you have questions, you know how to email me, and I'll try to keep giving you some hints as we move through this for the rest of the week. Thanks, 6-2. Hope to talk to you soon.